Our final skill for today is standard deviation. Standard deviation is a measure of how spread out the numbers in a data set are. So a few just conceptual examples before we start. If we had a data set like this, we can see that these numbers are pretty close to each other. 7, 8, 9, and 10. They're all like 1 apart from each other, so we'd have a small standard deviation here. In a different case, if we went from like 1 to 50 to 1,000 to 22 to 10,000, you see these numbers are extremely far apart from each other. We'd have a very, in this case, a large standard deviation. Why this matters, if you're looking at a data set that's really close together and you're trying to make a guess about what the next number is, you have a pretty good sense. You know that those numbers are pretty close together. Think about something like a stock. The performance of a stock has a small standard deviation. You have a pretty certain investment, pretty good buy there. If you have a large standard deviation for that same stock, it's a lot of risk. It could go up by a lot, could go down by a lot. You really don't know. So that's basically the usefulness of standard deviation. And honestly, out of all the stats we've done so far, it might be the most useful one for actually making predictions. So a really important skill here, there's a lot that goes into calculating it. And to be totally honest, the mechanics of calculating it are usually done by computers. Normally you punch in a data set and it spits out a value for you. Today we're going to go through the steps so that you understand what is actually being calculated. How are we finding these measures of spread? And again, after this lesson, you're going to have to know how to do this. But in life, mostly it's going to be calculated for you. But it's good to know what the calculator is doing. Because if you don't have a sense of that, you're just kind of blindly trusting statistics. And you don't want to do that. You want to make sure you know what's going on. So how do we do it? Let's take our first data set that we did. So from the first problem we had, it was a 7, it was 14, and 9. So there's our data set. And we want to, of this, calculate the standard deviation. So there's actually 4 steps. I'll write them off to the side. The first thing is you have to find the mean. After you've found the mean, you want to take the number, subtract it from the mean, and then whatever that answer is, you want to square it. So basically take 7, subtract it from the mean, square that answer. After you do that, you want to add all of the numbers from step 3 and take the mean. I should say from step 2. And then your last step is whatever that mean is, just take the square root of it. Okay, so let's go through these steps. So step number 1, 7, 14, and 9 add up to 30. We divide that by the 3 numbers in our data set, and we have a mean of 10. If that was too fast, you don't know what I did, take a look back at that first video that we posted. That's how we find the mean. Again, add it, divide by the number of numbers. Second, for 7, 14, and 9, we are now going to subtract each of these from the mean. So I'll have minus 3, 4, and minus 1. And we take these answers and we square them. So we have positive 9, positive 16, and positive 1. Step 3, out of all of these numbers right there, we are going to take them and add them. So there we get an answer of 26, and we need the mean. So we're going to divide 26 by 3. When we do that, we're going to get like 8 2/3 as our answer, or 8.6 repeating. Our last step is to take that 8.6 and take the root of it. And try to avoid rounding as much as possible here. More accurate, less rounding. And our exact answer without any rounding here would be 2.94. A bunch of decimals after that, but we'd say that our standard deviation is about 2.94. So to quickly recap, find the mean, subtract and square, find the mean of those answers, and then take the square root. So it seems like a lot, and honestly it is, but all steps that we can do, if we have these steps written out very clearly, will be successful. And finally, what does it mean to have a standard deviation of just under 3? Well, it means that on average, the numbers that we see here are about 3 or less from each other. Now, it's obviously not perfectly the case, but we would guess if we had an additional number into this data set that it would be within somewhere in the range of 3 of the center. So our mean here is about 10 of the original data set in blue, and we're guessing that all of these numbers are pretty close to 3 from the center, either way. So 3 under, 3 over. And it's, pretty accurate. The 10 and the 9 are both within that standard deviation, more or less. The 14 is a little bit further away from that standard deviation, but that's okay. And again, to conceptualize this, you have your mean at 10, and what the standard deviation is saying is most of our data is going to come between 7 and 13. And we see for the most part, it's pretty much true. Okay, so that is calculating standard deviation. Try these last few examples.